recorded. Okay. Yeah. So let's start. Okay. So this instruction says you will have a test on Wednesday through MyMathLab. Means you have to log in there. The test will be available right at 4 p.m. on Wednesday 25th, and then will be closed on Thursday 26th. So it's total of 24 hours to find a quiet area to do the test. So it doesn't matter when do you do out of these 24 hours. You can start at right at 4 p.m. You can just start at 12 a.m. and you can start it tomorrow morning at 10. So it's just up to you. The test will be available for 24 hours. Then when you click to start the test, the total time that you have to finish the test is 180 minutes. Okay, so your test is available for 24 hours from 25th 4 p.m. to 26th 4 p.m. But you have when you have started the test, how long you can do the test is just 180 minutes. So whenever you feel you are ready to do the test, go and log in on MyMathLab, click, and then start the test, and then that's just really 2 submission. So means once you have done the test, you can just, if you're unhappy about the test, you can submit one more time your solutions. Okay, and that's it. It's just really no extension, nothing to do. It's all through the MyMathLab for the half part of your job. And as you have done many times for your assignments, I expect you to write the work through the whatever you have done on MyMathLab. You just keep the notes and then you show it to me to get the extra credit. But here you must do that one. So the second part of your job is just write down your work when you are doing the problem and upload it on on the link that I have over here. Okay, so this link, when you click it, is just to upload your solution by Thursday midnight. So means to upload your solution, scan and upload your solutions after doing on MyMathLab. So that's just later. Okay, so you have about 8 more hours to scan your work and upload it over here. So here on Blackboard, I expect you to see the solutions and the work that you have done to get the solution. On the MyMathLab is already graded. You see what's your grade, and that's just really the grade. Okay, so that's just your 50% of your job. Another 50% is to upload your work on my link, and then I will grade it over there to get another 50%. And as I explained over here, so you just have you can just discuss with your friends. This is fine. I'm just telling you this is not cheating, right? So this is a take-home test. So when it says take-home test, it's fine to discuss with others, or it's fine to get help. But that's just really when you copy paste your solutions from somewhere, that doesn't make sense. Okay, so you make sure you are using your own work or solution to write it on your work. Okay, so when we say take-home test, this part is the most important part for me. So you might know what's the steps, but if you copy and paste from someone else, it's just showing directly to me. Okay, so this is just really doing someone else's, not his. At least for this last 10 weeks or 9 weeks, we've done something through the paperwork, and I know what's each student, especially because I have kept some of the quizzes. I know which students what his handwriting is. I know how it's just the way of writing for my students is, and that's just really reminding you, I know you, so then write your own word for each solution that you're supposed to upload it. Okay, but it's fine to get help from your classmates. Okay, not out of the class, from your classmates. And then this is 50%. That's it. I don't have any explanation for the test. If you have any question, can you please unmute yourself and ask questions about the test?
Yeah, I just wanted to clarify. So the questions are coming from MyMathLab, and we'll enter our answers in MyMathLab like we will with the homework, and that's 50% of the grade. And then the other 50% is how we write up our problems and show you the process for each problem.
Exactly.
Okay, cool.
Any other question?
So when we upload the extra credit that we've already done, do you want us to upload every single page? Because like I have 1 page per question. Or do you want us to upload like certain pages?
This is a very good question. Okay, so for this one, I know that's just a lot of work to scan, and here, even if I just want to see those pages, is a lot of them. So it takes about I will say 1 or 2 minutes just for Blackboard to open 1 page for me. So if the Blackboard want to open 1 page for me, it takes time. So if, for example, you have 100 pages for 100 problems that you have tried, that's just really great question, because this is a lot of them. Okay, I understand this is a lot of them. So then I suggest you the alternative way. So you can just really upload, and those just really for those of you have tried already on the something like iPad, something like Surface Pro, something that you have already have the typed or scanned or whatever you call on your site. So then you can upload it. This makes sense. Okay, so I've seen if you are just doing on your tablet or laptop, that makes sense if you do it on that part. But in general, this was actually what I was going to explain. Let's say you have just the paperwork, it's just the 1 page or however it is. I prefer to have individual meeting for you, and then you can just really show me through the individual meeting, okay, I've done this many problems on the camera. Okay, that makes more sense for me if you don't want to scan 100 pages, and that's just really nonsense, right? So we have many things to do. Even if it's just really uploading 1 or 2 pages and then here downloading to see what are the pages, it takes a lot of time. So I will say, if you don't have time or you don't like to just scan all the pages, that makes a lot of sense for me. You just need to email me, or somehow in individual meeting start to what is it, show me what are your pages or how is your process, as you have done last time. It was just really short checking on your papers that you have done your job. Any other question?
Professor, where are you gonna post like these recordings and then like your lectures like from last class and from this class?
Okay, this is a good question, Tristan. So let's just say, okay, so you have had always what you call course information, huh?
Mm-hmm.
And that's course information. I didn't put for yours. Okay, so for yours is on files. Okay, but I will put the Zoom over there too. So this is on your files. So if you have Zoom recording meetings, it's just right there, and I'm sending you to the YouTube. And I think we have done only one. Okay.
Yeah, we've only done one so far.
So, and then for the other part, which is just whatever I have on OneNote, it's just right there. Okay. On lecture
Okay,
note.
great. Okay, thank you so much.
I have put 2 different. Okay, so as you see, it says filled during the Zoom meeting. Okay, so this is filled one during the Zoom meeting.
Okay. Okay, great. Thank you so much.
No worries. Any other question?
I had a follow-up question based off of the turning in the extra credit for the MyMathLab homework. Would it be easier for you if we maybe like just took a video on our own of it and then emailed it to you instead of setting up personalized Zooms?
No.
Okay.
Then I have to open that video and upload it and then somehow download it again, and it's just really that is longer process. I think at the live meeting, you can just stay a little bit after the class. So it's just 10 minutes after your class and show me your papers. That's it. Or just come 10 minutes before the class, or half an hour, because I'm available about 10 minutes before the class time. And then after the class, I'm free. So I can be available more. So that's just really, if you don't have any class, if you don't have any class, you can stay more. But if you have a class, you can meet me just different time. But that is
okay. Thank you.
You're welcome. Any other question?
So on the day, oh, sorry.
Yeah, I was just gonna ask, are we having a lecture on Wednesday, or are you
Yes.
just gonna post it and then are we gonna?
I am going to use every single minute of lecture time. Sorry.
Okay, no, that's fine. I just wanted to know if we were having lecture.
Yeah, we do have a lecture. Any other question?
For the midterm, are we only using, do we only get like one submission for each question?
I don't know. That's a good question. As I explained, the setting for the test on my MATLAB is very different than the setting for the assignment. For assignment, you can just have per question 5, I believe, submission. But for the test, it's not like that. This entire test, 2 submissions. It's not per question. So if you click and start to do the test, so that's option number 1. If you submit it, you are done for option number 1, and you have entire 22 problems. And then the second chance is just really start over with different problems with different numbers, and then that's your second chance, and that's it. You submit entire problems all together.
Okay, thank you.
Any other question? And it's not really for always. Okay, so this test is basically, I have decided to make it easy and make it take-home test. Okay, so it doesn't mean it's always like that. So maybe for next one, we just change the method and we can just do it through the Zoom as you open all your cameras, and then I'm watching you right over here. Okay, so I can just watch you at the same time. That's just might be for next test, we don't know. Okay, for now. But the only thing that may the only thing that I'm sure about it, I will have 2 more midterms. Okay, so one for chapter 15, because it's just really easier for students to have one subject each time. So chapter 14, it was just completely independent by itself, and then chapter 15, and then chapter 16. So then I will have 2 more of these tests. And then if the only thing is, I have had really hard time this weekend to set all of these things. The only thing is, all I need to do about the course is just go on here and see what's going on next week, and what's the plan for the entire remaining 6 weeks. So you just really click on this weekly base, and then you see what is due day and what we do each week. Okay, so this is just really, I try to organize it again based on the changes that we have had, and that takes a lot of time. Hopefully I'm fine by now, but I think John can email me if there's anything wrong, remind me, so just extend it, or it's not supposed to be midnight, so you made it just later or earlier. So that type of thing, I can just change it later, but that's just really our plan. It's all scheduled here. Thank you, John. Okay. So then let's just go and continue the lecture. We are trying to do chapter 15, and this is just all integration of what is 2 variables function, 3 variables function. And again, I don't promise about the recorded video, because it's just really somehow taking time, because they are long usually, and I hope it's not stuck somewhere. It's just continue to converting, and then I can upload it on that YouTube channel. But I do promise on my lecture notes, because that's on my hand. I can just right after this meeting, I can just send it to the Blackboard as I showed you under the file. Okay. The plan for today is to cover at least 2 sections, which is, one of them is really very short, which is 15.3. And for most of the books, that's not really a different section. It's really same as the other 15.2. I'm not sure. Sorry, let me back to the 15.2. I'm not sure whether I have finished that one. So this is just back to this one. I think I have one more nice example. Yes, I do, right? Please don't go slowly. I believe I haven't finished this one for your class. Anyone can remind me? I made the limits of integration for this one. Okay, so that was my nice problem that I haven't tried, and this is just really one skill I need to teach you. Okay, So I will go back to the 15.2 and I will continue first the two more problems that left over here, and they are nice problem. These are just really kind of problem that we expect to get in the homework in the next test. So this is example number 5 on this lecture note. What's the goal of this type of example is changing the order of integration, okay? So that's just what you have practiced in your group work. And if it says directly change the order of integration, this is perfect. But if not, how do I know this is changing integration? Okay, so how do I know this is a change of order of integration? So for your group work, directly ask you to change the order of integration, but not here. If you remember in calculus 1, you have had non-integrable function. So one of these non-integrable function was really e to the x square. And then if you say why this is non-integrable, why this is going to be non-integrable, because if you have had just e to the y square and dy, and then if you try to call u to be, for example, y square, which is your exponent, then your derivative is 2y dy. So then you will have e to the u, and dy is 1 over 2y, and then whatever is just your du, which means I don't know how to replace y. So I don't know how to write every single element of this integration in terms of the u substitution that's supposed to be, okay? Because there is no y right there, then I don't know how to integrate, okay? So that's just non-integrable. This is non-integrable fun. In terms of the non-integrable, okay? So this is in terms of the y, but I know if I can switch the order of integration, so it's fine. I can integrate it. In terms of x, e to the y square is going to be a constant, so I can easily integrate it, okay? So the problem itself, it didn't say change the order of integration, but I know this is not possible to do as it is, but if I switch the order of integration, it will be possible. So the only thing that I have to remember, what is the order of integration is really what is the limits of integration right over here. So that tells you your x's must be between 0 to 1, and then that tells you if I have this, which is saying the y has to be between x and 1, okay? So this is my region of integration. And we have practiced several examples last time that says you can't reorder this integration easily by switching dy dx, because if you remember, we have practiced just the problems with changing the order of integration was really two different types, right? So if you have type 1, then you have to have it two different pieces of integration. If you have type 2, it was just really one piece. So these are not easily just switching these two pieces, right? So that doesn't make sense. If you are switching the order of integration, you have to really make the graph one more time, set the limits of integration one more time. So for this type of problem, there is no way to do anything unless you see the graph. So always step number 1 is make the region of integration. Okay, for region, graph the region of integration. For region of integration, the thing is, I have to remember the main part that you need to graph is just this part. I mean, the inner one is just helping me to get the graph. So if you remember the inner one is the most important part, then it's easier. So what I supposed to graph is the region that x's are bounded between 0 to 1 and the y's are bounded between x to the 1, okay? So then the graph of this is going to be y equals x is down, right? The bottom piece is y equals x. The y equals x is the bottom piece. okay? And then the other side is y equals 1. So this is going to be the line of, let me change the color to be somehow different. Okay, so this is going to be the y equals 1, right? So that's just the region of integration, right? So this is the region of integration. It matches with these x's is between 0 to 1 too, right? So x is between 0 to 1 is fine too, okay? So then this was type 1 or type 2 originally? What do you think? What was the original one? Is it type 1 or type 2? Hey guys, type 1. So originally it was type 1, now I need to change it to the type 2, okay? So when I need to change it to the type 2, so means I have to write the limits of y first. So type 2 is limits of y first, so you're moving from 1 to the 0. So this is the minimum value of the y constant, this is the maximum value of the y constant. Again, don't forget the first one must be always constant, okay? First, limits of integration must be always constant because you need to end up with the constant after the integration. So then the next thing is to write the limits of the x. If you want to write the x, so you have to move along the x-axis. So you have to move along the x-axis. So you go from left to the right. So the left side is going to be your what is it, lower limit. Left side is going to be your lower limit, which is just really y-axis. So your y-axis is x equals 0, and your right side is just that equation. But since you're writing your x limit, so it has to be in terms of y. Okay, so does it make sense by now? Is there any question? Is there any question? No? Okay, so then whatever it is inside, now I can integrate it, right? So your limits of integration is set. So I will say you're done because that's 80% of your job. So after that, I don't think we have any problem to integrate in terms of the dx from a constant function. This is already a constant function. You can integrate it in terms of the dx, which is just going to be itself, and then x plug in from 0 to y, and then dy. And then the next step is plugging the values, which is giving you upper limit of the y minus 0, which is all 0. And that's it. That was exactly the problem that we have had right over here to do the u substitution, huh? So if you do the u substitution over here, that you have had missing y, now that missing y is coming. So then you can just do whatever you have done in the calculus one as u substitution. Sorry, that was du equals to y dy. So that is just going to be e to the y itself half, and then plug in 0 to 1, which is giving to you half of e to the 1 minus half of e to the 0, or half of e minus 1 minus 1. Does it make sense? Do you have any question?
I'm sorry, for the when you had from 0 to y in the beginning of type 2, from 0 to how did you and so it's in terms of the x, right? So because it's the lowest, because it can't go below, because we originally said that we can't go below 0, and because y equals x in this case.
You have always from left side to the right side, right? Left to the right, because that's how the x-axis is. Whatever is the most on the left is sitting here, which is
Okay, in that case, 0.
y-axis, which is x equals 0, the equation of y-axis, which is x equals 0, and whatever is on right is your upper limit, which is x as a function of y.
Okay.
Any
Good.
other question, guys? Any other question? Okay. So the next one is just really what we have had actually into 15.5. This is just reminding us whatever rules that we have had already in calculus 1. It works nicely over here, including you can split your integration if you need. So if you have integration of addition, you can just separate this integration. If you have a constant, it's perfectly fine to factor the constant for any type of integration. It doesn't matter it's single, double, or triple integration or more. You can always factor the constant. And then for inequality, I told you last time, so this is just okay to integrate both sides of the inequality. So means it does not change my, side of inequalities. Okay, so it's positive, it says positive, is negative, it says negative. So this is what we have done last time. And then that notation is just really union notation. So if you're having union of some pieces, so if you need to break down your pieces of your region to be, for example, one of them is type 1, the other one is type 2, or both of them is type 1 or type 2, but you can't just say it in one single integration. So as we have done for the previous example before this one, so you have to take care of one piece and integrate completely, take care of the other piece, integrate completely, and then add up the result. So this is really telling us you can just split out the region of integration as many as you want. Okay, so if it's splitting out to 2-3 pieces of the region type 1 or type 2, we can get the result of each one and then add up the result that would be for entire region. Okay, and actually this part, which is just finding the area in your book, is called 15.3. Okay, so this section in your book is separate and it's not really like on any other books that we have here. So finding the area by using double integration in your book is entirely different section. Okay, so then I'm going to do that one first, and then this is just really one more example. Okay, so 15.3 is a different section for you. It's just finding the area, and I'll explain it separately right now. That's another property. So before moving to the new section, this is another property that we have had in what is it, single integration, and this is just the double integral version of that. What it says, if you have a function which is bounded function, what does the bounded function mean? You know what's the maximum value of your function, and then you know what's the minimum value of your function. Okay, so these functions, they are really limited for us in this level of calculus. So for example, sine is one of those, because I know maximum value for the sine is going to be 1, the minimum value is going to be -1, or cosine is just one of them. So I know what's the max and min of the cosine and sine. So there are really limited number of functions that you call bounded, means it has the maximum value, it has the minimum value, but other than that, there are all functions like polynomials, your natural log. So all of those functions, they are not bounded, they are going to infinity. Okay, so it says if your function is bounded, so you can integrate all sides of your inequality. So if you have, for example, sine of x, you can start to I left my n. Sine of x, you can start to integrate all side of inequality. What did I do? Something erased. So this is sine of x. So you can start to integrate all side of the integration by two double integration or single integration or triple integration, however it is. Okay. So that actually is a nice rule. If you start to integrate all of this side and then this side and then this side, so that tells you, you will, if you don't know how to integrate the middle one, at least you will have a nice estimate of that. If you don't know how to integrate, at least you have a nice estimate of that. And that's just really one example. Okay, so I can explain better if it is just this example right over here. This is the function that I don't know how to integrate. So this function is not possible to integrate. So then I can only estimate one thing, that is really what is the highest value that I can get from this integral and what is the lowest value I can get from this integral. So this is not possible to integrate, but I can estimate it. How do I estimate it? Because this is type of the function that I have learned is bounded between -1 and 1. This is a function that is bounded between 1 and -1, okay? So then the product is what I need to be bounded, and that's just really stay the same thing. So if you have two numbers between 1 and -1 and you multiply them, still the result is between 1 and -1. And then since I've tried this function, or that's my goal to make, I need to have E of this. So this means I have to have E of this, E of this, E of this. So basically you can E all sides of inequality. You can natural log all sides of your inequality, as you can integrate all sides of your inequality, okay? So this gives you e to the -1, which is a constant, e to the sine x cosine of y, and then e. Is that fine by now? Makes sense? Keep going. And then this is the goal, get the double integration, right? So that's the goal. I'm going to add that goal, means just double integral all sides, huh? So I'll just do the e to the -1 is a constant, double integration of dA, and then this is e to the sine x cosine of the y dA, and this is going to be e dA, okay? So now I need to know what would be the double integration of the dA, okay? So what would be double integration of the dA is just really, as I said in your book, what we call it in 15.3, and I'm going to cover, it's not really covering, it's doing more examples, but I can just quickly say, this is really what we call area of region. Area of the region. So what's the region? Is this. The region is a circle with the radius of 2. The region is a circle with the radius of the 2. So that's just the area of the region, which is the circle with the radius of the 2, which is going to be pi r square. Okay, so you have then e to the -1 as a constant, then you have area, which is 4 pi, then you have double integration of sine x. So imagine your function itself was just really ugly. There's no way to get the value of that function by hand. But at least by this simple, I will say, process, which is just really integrate all sides, you could just say the value is going to be, estimate value is going to be at most e times 4 pi, at least 4 pi divided by e. And that's it. That's the answer. Any question about this one? Does it make sense? Okay, move on. So let's just move on to the 15.3. As I said, how do we know something is not integrable? So you're not being integrable for most of the cases is easily. So for example, if you have cosine of maybe y square and then dy. This is just what you are going to do it by u substitution, and then the du has to have, where is my pen? Yay. What happened to my pen? I need to bring the highlighter. I don't find my highlighter here. Yay. Who is using the OneNote? Where is the highlighter? This is home. This is where we are. And this is where it's supposed to be. And then I lost my nice highlighter was on top. Anyway, I don't find it. Okay. Okay, so how do we, that was the answer of the question, how do we find something is not integrable? So most of the cases, I will say 90% of the cases is clear for us. Draw. Yeah, that was there. Thank you. So most of the cases is you are missing whatever you're supposed to just call your differentiate of your u. Okay, so that's just the problem that I can't integrate it. Does it make sense, John? Yes. I start to integrate. Cancel out y what? So the original problem has integration of sorry. The original problem has integration of cosine of y squared dy, and then if you have u equals y squared, and then you call du to be 2y dy, so then you have to replace dy to be 1 over 2y du, right? So when you go over here, so you have cosine of the u, and then you have du, which is 1 over 2y, right? So your problem is, can you write y, because it has to be all in terms of the u, right? Can you write y in terms of u? So for example, you might say, okay, why not the square root? So you can just say this is the square root of u equals y, assuming that the y is positive if you square root both sides, but it could be plus minus, and then that would be cosine of u divided by 2 times of rad u, and that's just what I don't know how to integrate, right? Does it make sense? So it's just really somehow getting more complicated as you do the u substitution, only because that y is missing. So then I will know if I use the u substitution and I'm missing that part of the variable that must be part of my du, so that's not possible to integrate. Okay, thank you. You're welcome. Any other question? I think I had one before the John. Oh no, that was my question. And Johnny, and who answered me? Yeah, John, you answered me. Okay. So for this 15.3, which is just really same as 15.2 for most of the book, in your book is different. I'll just do some examples. So before doing that examples, this is just reminding you from Calculus 1. So when you were in Calculus 1 or somehow maybe in Calculus 2 classes, when the question asked me find the area between two curves, it was just really make the graph. This is the top curve, and this is the bottom curve, and then say this is just the area between two curves, right? So then the area between two curves is going to be in Calculus 1 level. So get the intersection, which is just A to B, and then you just say y top minus y bottom. Do you remember this process? That's just really the single integration way of doing the same problem. So then since we now learn how to do the double integration, so this is just really same thing that you have done in what is type 1, set the limits of integration to be constant for x, and then next step you just take care of your y. So it means you're moving along the y, and you just say lower limit is the lowest one, and then upper limit is going to be the highest one, and that's just the limits of integration. Okay, so it seems in this case you do not have any integrand when you are finding the area, because if you just get the integration of one is going to be y, and then you plug in the y value, then you go to this part, right? So you plug in the y value and then you go back to this one. So this is really same as what we have had in Calculus 1 if we knew what is the dy or what is the double integration after taking care of my constant limits of the x. So it was the next step, set the limits of integration in dy. So this is reminding us, I could do it in calculus 1 version and still I can do it, but that piece that is right in the middle is really plugging the limits of integration after taking care of the inside, which is the y integration. Can I reorder it? Yeah, because I can have type 1, type 2, but I need to remember if I'm looking for the volume, it's just really double integration of some surface. If I'm looking for area, it's double integration of dA. Okay? So that has integrand, that does not have. So this is possible to do that volume and area both by using double integration. One has integrand, one has no integrand, okay? So this helps us when we go to the triple integration because it does give you the same idea. So for now, I want to try some example. And that's what I said. It's just really not that much lecture. It's just writing the example. So for example, it says find the area between, between two given lines. Okay, so I just try two given curves. Okay, so then I'll try some pieces because it's just really same wording, different limits. So if I start from the easy one, I will have between x equals negative y squared, and then the other one is y equals x plus 2. Okay, ready? Ready? Okay, first thing that I need, graph. Because if I don't see the graph, I don't know whether it's a type 1 or type 2 or which one is easier or what's the limits of integration. Maybe it's a square, maybe a rectangle. I have no idea, okay? So this is if I just plug in x equal, so this is x, this is y. If I plug in x equals 0 is 2. If I plug in y equals 0 is negative 2. So this is just 2 positive, sorry, 2 negative 2, x is 2 positive. I'm so sorry. X is 2 positive. So x is 2 positive, y is 2 negative. So this is just the line of this is the line of y equals x plus 2. So then the other one is, before making the other graph, it's better to get what's just your intersection, because that gives you the idea where you need to, x is negative y square, x equals negative y square. Okay, so that gives you x equals negative, plug in y to be x plus 2 to the second. Is that fine? So intersection is plug in here from here. So that gives you x equals negative x to the second minus, sorry, plus 2 times 2 plus 4, and that is going to be minus x squared minus 4x minus 4. And then if I subtract negative, x equals 0. So minus x, I could put it all the right side, then it was all positive. No, that was just better idea, sorry. Why not everything on the right side? And then everything is positive. So then you have 4x minus, so it's 3x plus 4 equals 0. So that gives you It gives you what? Product of 4. Oh, that's a good question. Why? This is a very good question. What is the intersection of these two lines? This is x equals negative y square, and this is y equals x plus 2. Yeah, that's just really correct. What is the intersection of this one? Hey, any idea, guys?
When you moved everything to the other side, why did you subtract x? Wouldn't it be plus x since you're moving everything over to the x's side?
Oh, okay. So thank you. That was a mistake, huh? So I was going to say there is no intersection. So that was just, you're right. Thank you. So that was a 4 and 1, huh? Thank you. Okay. So then your intersection is going to be x equals negative 1 and x equals negative 4. So negative 1 and then negative 4. Okay. And then what's the graph of x equals y square? So x equals y square goes this direction, huh? X equals y square goes this direction. Since it's negative, it goes the other way. At negative at 4, what is it? At negative 4 plus 2 is negative 2. So this value, if I just fix my unit, that would be more helpful, because that has to be negative 2, that has to be negative 1. Okay. I want to make that parabola somehow to pass this point. Somehow to pass this point. Okay. Finally, so this is y equals x equals negative y square. Okay. So that's my region of integration. Is it type 1 or type 2? Is it type 1 or type 2? Type 2. So if it is type 2, means I have to set the limits of integration for x first. So if I set the limits of integration for the x, what's the minimum value of the x is right here. What's the maximum value of x is right there. So means you are moving all the way from negative 4 to the 0. And then if I want to just say, oops, what is it? dy, right? So this is what I'm writing as type 1, huh? So I wrote first my x's from the minimum to the maximum, and then is the 10 for the y's. So the 10 for the y's, so let me bring just some different color here, maybe pink, just lighter. So when I'm moving on the y, I have to hit this one first and this one next, right? Do you see the problem? That your friends all said is type 2 is not type 1. Do you see what's the problem? It is not easy to write it in type 1, and then your friends all say is type 2. Do you see what's the problem, which was easier to do in type 2 than type 1? Because if you write it in type, 1, if you write it in type 1, starting from starting from this line, your region is different. So your limits of integration on right side is from the parabola all the way to the parabola, but on the left side is going to be from parabola to the line. Okay, so that's just actually from -4 to the -1, and that's different if you go from -1 to the 0. So you have to write it in two different pieces. Okay, so this is the, if you're supposed to write it in type 1, so you have two pieces, because from if I use the highlighter, if I'm moving from -4 to the -1, my limits of integration is just going to be from here, which is the bottom piece, to here, which is the top piece. Okay, so means your -4 to -1, your bottom piece is going to be dy. And the y. Okay, so what is the bottom piece? So you have x equals -y squared. So then you have -x equals the y squared. So then you have -x plus minus the y. Okay, so minus piece of square root to the piece of square root to the sorry. It's from negative piece of your square root, which is down here, to the positive, which is the top one, which is what? Which is x plus 2. And the right piece, I just make it different highlighter. Maybe if I make it green, so it's right here, which is again moving from negative piece of the parabola to the positive piece of the parabola. Does it make sense? We don't like this one. It's really tough. Okay, but that's why your friend says it's easier to go with the type 2. And I'm going to make another graph. I don't want to have a messy graph one more time. So let's just quickly make the graph as we have had originally. So there was a -4 right over there, -2 right over here. And then we have had this curve going to be like this. And then with the green line, we have had like this. This is y equals x plus 2. And this is x equals -y squared. So then that was just originally region of integration. And then if you're supposed to write it in type 2, so you start with the y, which you go from the smallest value of the y to the highest value of the y, which is just from here to here. And then for the x's, we go, let's just make it different. So we go always from x direction, so which is from left to the right. So left to the right, so left side is the lower limit. Left side is the lower limit, which is x equals minus y plus 2, and then x equals y minus 2. And then the upper limit is this one. Okay, x equals minus y squared. So again, left, one more time if I use highlighter. So left side is the line, which is right over here. And then right side is the curve, which is right over here. And that's it. Since you are finding the area, you do not have any integrand. So you just need to integrate first inside and then that gives you x, then plug in y minus 2 to the y square, and then keep going. Is there any question about the setting? Is there any question about the setting? No? Does it make sense? So let's continue just to integrate this one. It has negative 2 to the 1. So if I plug in upper limit is minus y square minus, if I plug in lower limit is just minus 2. And then the next 10 is y. So that is just minus y cubed divided by 3. This is minus y squared divided by 2. And this is 2y. So then you have negative 2 to the 1. And then whatever is the value, you plug in negative 2. And then plug in 1. Okay. Is there any question? If you don't have any question, let's just try one with these. Three lines. Okay. Are you ready? Ready? Okay. So this is, one more time, let's just check I wrote the problems. Yeah, correctly. So this is going to be, first of all, the intersection of all these three lines. So you have y equals 2x, intersection by x equals, y equals x half. So that's the 2x equals x divided by 2. So then 2x is 0, right? So however it is, it's just really x equals 0 is one intersection for this one. So because these two passing through the origin, this is for these two lines, and this is for these two lines, right? And that is going to be 2x equals 3 minus x. That is going to be x half equals 3 minus x. So I will move this one is 3x equals 3. So that gives me 1. This one is x half plus x equals 3. Half plus 1 is 3 half. X equals 3. So x equals 1 half. Is that true? You do. 1 half. So if I have the origin, I have x equals 1, I will say, maybe if I make it bigger, that's easier. So this is 1, this is 1 half. So this is 1 half, this is 1. Because that's enough for us to get that values. So is it possible? No, because I need the 3 units. So that's just going to be too big. Sorry, that's not a good idea. It's going to be too big. Okay, so this is 1, this is 2, and then 3, and then 3. Okay. 1, 2, and then 3. So if you plug in for this line, if you plug in x equals, sorry, you can see for this one, if you plug in x equals 0, y is 3, and then that is if you plug in x equals 0, y is 3. If you plug in y equals 0, x equals 3. So this is making with the green. Y equals 3 minus x. And then if you have x equals 1, 2, Okay, so I need to be careful about y equals x equal y equals x, sorry, y equals 3 minus x, and then y equals 2x. Intersection is at x equals 1. Okay, so it has to be somewhere here, and that's almost good unit for me. This is y equals 2x, and then for the other one which is this and this, intersection is at half. So if this is the half, and what is the half? I don't know. I need to find out, right?
Professor?
No.
I think x should equal 2, not 1/2.
This one? Multiply by 2/3. 3 by 3 cancel out. Yeah, that's 2. So it's somewhere here, huh? Okay, so if I plug in x, thank you again. If you have 3 minus 2, the y value of 3 minus 2 is just 1, right? So if you have 3 minus 2, the y value is 1. So it's just almost, if we get here, so it just passes this point. So maybe I make it with the orange. Orange is too close, so let's just say blue. This is going to be, which one? Y equals x divided by 2. Okay, so since that was the goal, this is very similar to one of your worksheet. I mean, one of the problem of your worksheet. And then I don't think in either one is type 1 or type 2. We can just do it in one single integration. For either one, we have to do the two different integration or setting for integrals. Can you please tell me, do you prefer type 1 or type 2? Do you prefer type 1 or type 2? And as I said, in either one, we have to just do it 2 times. Type 1, okay. I have integration from dx. So if you do in type 1, so this is just where is the breaking point is, right? So that's just really where the breaking point is. So if you go from, let me just highlight it with the this color. So if you go from here to here, and which is from 0 to 1, that would be different when I go from here to here, and which is from 1 to 2. Does it make sense? So then I have dy, then I have dy, then I can just go along the y-axis to see what I see. So again, I go back to the same color. So for this one, when I am moving, the first line that I hit to start is right over here. The last line I hit is just right over here. So my lower limit this time is going to be x half, and the upper limit is the red one, which is 2x. Is that okay? Then I change my color for the same blue color that I have used for the other piece. I moved it along the y direction because I'm writing for the y. So the first thing that I hit is the blue one. The last thing that I hit, the green one. So I'm moving in this piece. The blue is the start point, the lower one, and then the green is the top one. So I started from x half, and I ended with the green one, 3 minus x. Okay. Since it's finding the area, there is no integrand. So you have to get the number from here and then add up to the number from here. Is that okay? Does it make sense? Is there any question? Is there any question? Any question, guys? I'm going to stop for maybe 7 minutes if you don't have any question for the break, but I'm here if you have any question to add. If not, I'm just going to move to the new section. Okay, so 7 minutes just break for now, and then we are moving to the new section, which is just brand new type of integration. But I'm waiting for your questions. If not, you'll rest for a few minutes.
Professor, I have a quick question about the test coming up Wednesday.
Mm-hmm.
So I was wondering, do we have a full day to complete the test and we can pause it if we'd like, or does it have to be all done in one sitting?
Okay, so the test is available in full day, but if you start the test, you have to finish it in once for 180 minutes. You can't come back to another. So then that's why I gave you 24 hours to find a quiet area for 180 minutes.
Okay, got you. Thank you very much.
You're welcome.
So, Professor, do we have 2 tries of a 180-minute test or no?
This is, yeah. When it says to try, is the to try for entire test. So for assignments, you have, for example, 5 tries each question, but for test setting is completely different. So when it says to submission, so to submission means you start to do the test and you finish it, press the submit, and you get, for example, 95%. And then you say, okay, I will try one more time to see whether I can get 100%. So then you have to redo all the problem one more time because it changed all the problem for another 180 minutes and then press the submission. If you don't do that, so the first try saved. So always the best result will save for you.
Okay, thank you.
Okay. The only disadvantage of this type of classes is I have to sit all day long for teaching. So that was always when I was coming home and I was complaining, why I'm really tired standing on my feet an entire day to teach. Now I'm really getting what was the advantage of standing on the feet. It's a lot better than sitting. So most of the students are sleeping on the bed, listening to the lecture. At least somebody is pacing, that's fine. But for me, I'm writing, so I can't just work as I'm writing. I can't do that many jobs at the same time. But as long as you are safe, healthy at your place, so we are really lucky that we can continue our job. Okay, so it was just really boring if we couldn't do anything, even just your classes or your education is not delayed anymore because we have this advantage of working and continuing our job. So for most of you, you have a plan to graduate in some day, to get to the job, or many things to do after. So we are really lucky that we can continue and our job is somehow doable through this technology. So let's go back to the, let's go back to this one is just a new section, brand new integration. But if you don't remember what's a polar coordinate, still is fine. That's just something that we covered in Calculus 2. So this is just when we need to use the polar system. So if you remember in the first day that I have started chapter 15, I said, whenever you go further, you will learn somehow shortcuts. So it's easier to do the job in 15.4 when you have a polar coordinate techniques to do. But you might do this type of problem in previous sections, but it's just really harder to set the limits in integration and to integrate. So why or where is easier to do the in polar system? When you have circles. Okay, so just quickly remind you, if you don't remember what's the polar system, let me just quickly remind you. In the polar system, if you have xy, which we call it rectangular system, the points are like this. You just have one x and then one y, so that's just giving you x and y. But for polar system, you have one the distance from the origin, which we call it the radius, and then one the angle with the positive part of the x-axis, which we call it this theta. So the thing is, in Calculus 2 version, you might have negative r, you might have negative theta, but here in this version, as long as it's possible we do everything in positive. At least I'm sure we never have any r negative, because that was a lot of confusion for students. But the theta might be easier somehow to be negative, but the r is always positive. Okay, so this is a good news. And then if you don't remember what was the relation in polar system, x is adjacent, so it's r cosine, and then y is r sine. So this is when you're having in polar system and your plan is to moving to the rectangular coordinate. So those are the equations. And then if you have rectangular coordinate and your plan is to move into the r and theta, so then you can just write r squared is x squared plus y squared, and then theta is the tan inverse of y divided by x. Okay, I will tell you that's how much I need from your previous course. Okay, so polar transfer to the rectangular, rectangular transfer to the polar, and then what do we call radius is the distance from the origin always, and what we call angle is just really positive of your unit circle. Okay, so this is what we call polar. But then I was just going to say my job. What's my job? Where I do need to use this type of polar coordinate. So it has to be circle region. So if it is a circle region, somehow ellipse region, that's easier to do in polar. So you can compare right now, at least for this problem, right? So if this supposed to be from, for example, type 1. So if you're supposed to test this one in type 1 before just moving to what we call it in polar, so you just say, okay, it's just going to be all the way from -1 to the 1, which is fine. And then for the dy, you must move in y direction. And that tells you, since you are writing for y, you need to solve for y. So it's plus minus 1 minus x squared. So this is a negative part of your circle, and this is a positive part of your circle. Okay, so means this is from negative part of the circle to the positive part of the circle. It's not bad, it's possible to do. This one actually is the right one, is really harder, but this is possible to do. But remember, if you start to integrate this one for 1 minus x squared, integration of 1 minus x squared, you must do trig substitution. And then I promise you, you won't use this type of trig substitution in this course. So that's just a tough as far as integration, not setting the limits of integration. But instead of doing that, let's just look at what's just the what is polar version of this. So this is the limits in polar version. Oops, that was too dark, sorry. Why jump down, sorry. I was going to change the color. It seems it's busier to use the eraser. Okay, because it was too dark. So as you see, this is just easily writing the same thing in polar. How does it work? It says my radius is working. Now I need the dark one. Okay, so my radius is moving from 0 to 1. So this is from 0 to the 1. And then it's always from 0 to 1, because that's the radius of the circle. All the way is always from 0 to 1. And then my angle is moving, here is the 0, is moving like this. So it's just moving from 0 to the 2 theta. So instead of having that trig substitution, as you see, all of these things are constant. All of these things are constant, right? So it's easier to integrate in polar because of this is constant, this is constant, this is constant, this is constant. It's just really rectangular again. Okay, and then the right one is just really tough because it's not possible to do in type 1 and type 2. So I'm going to test it one more time to see how much you need the polar, because you see, if you go from if I use the highlighter, if you go from here to here, and then here to here, and then here to here, okay, so your limits is changing. So from here, you are starting from here and ending by this. And then if you go here, you're starting from here and then go by this. And then here, you're starting from here and go by this. So you have to break it in so many pieces to integrate. Yeah. Unfortunately, I can't stop my kids. They are just doing their job. So he's practicing, is just playing with the piano. Yeah. Sorry. Okay. So yeah, I know. Thank you. So as you see, instead of doing that thing in what is it? In rectangular coordinate and make it in this many pieces, and it's really tough to integrate. That is just simply writing the radius is moving from 0 to 1. Then I need again the dark one. So is moving from 0 to 1. So this is how the radius is moving, because that's it, the circle. And then the what is it, the angle is just really 180, right? So your angle is starting from here all the way to here, which is from theta equals 0 to the theta equals pi. So these are really constant, these are all constant, so integration is easier than really make it in 3 pieces if it's type 1, type 2. So it's necessary to learn another technique to have easier job, to have the shortcut for integration. Okay, so, and for integration, as I said, for a polar system, all I need is really this much. This page is really enough how to transfer from one coordinate to other coordinate and how these two are related, if you don't remember. And then for the graph, I let you use your calculator to graph the something that we have learned in previous course. So what's the goal to transfer every single thing to the polar? Is really some kind of U substitution. So when you were in calculus 1, so you have had U substitution because if you have had integration of f of gx and then dx, so you could just really call this one to be u, and then you need to call somehow to be du, and then change the integration to help you to integrate, to make your job easier. So it seems this type of new variable, instead of I say u substitution, is just going to be u and v substitution, because there are two variables. You rename it or changing both of those variables, okay? Obviously to make your job easier, right? So this is just the purpose. If you remember, one of the things that I said for the just defining any type of integration, so we will have 5 types of integration. All of this is just really chopping to the pieces, pick a lucky point, make a Riemann sum, and then that's just what we call a new type of integration. We have done once in calculus 1, once here in double integration, and we can do it one more time for the polar system. So what it is, so your given V region is just really going to be between it's here. So it's going to be between the radius to be A, the radius to be B. So means the circle with the radius of where exactly do you need to go? Here, the formula. Okay, no worries. Move on. Okay. So what we have, as I said, what we want to do is just really chop the region to the pieces, then pick a lucky point, and then make a Riemann sum and define what we call polar coordinate integration. Okay. So for now, we started from rectangular in polar. What is rectangular in polar? All of these are numbers. This is a constant, this is a constant, this is a constant, this is a constant. Okay. So when we say r equals a, this is just really one circle with the radius of a. Okay, so we just don't have the entire one. So this is one circle with the radius of a, and this is one circle with the radius of the b. So this is just really r between a and b. So this is really r between a and b. This is r between a and b. And then when we just say the angle is starting from alpha and ending by beta, means you're starting from here, which is alpha unit, ending by here, which is beta unit. Okay, so that's just really a rectangular region in polar system. Okay, so I'm just going to chop it to the pieces. Okay, and then chopping to the pieces means just really you will have something like this, and then chopping to the pieces means you're going to have something like this. So in theta direction, you have pieces between A and B. Oh, sorry. It was between alpha and beta. And then for radius, you have between A and B, right? For radius, you have between A and B. So then you're making to the pieces. So if you want to pick a lucky point right over here, so this is just going to be the ith direction, okay? So I'm going to say that could be theta I, that could be theta I plus 1, and this could be Ri, this is going to be Ri plus 1, Ri plus 1, okay? So that's my ith piece. Right over there is my ith piece. If I want to pick a lucky point, I must call it R star theta star. Again, there are many options. I can say I pick this point, I can 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 pick the midpoint. So it's just I call it lucky point, okay? So then I will evaluate the function at that and multiply by delta of whatever is the area of that region. So area of that region is something which is special, okay? So area of that region, if you agree with me, is not really dx times dy, right? So it's not really a perfect rectangle to be width times length. It's somehow something like a sector, a piece of a sector, okay? So I'm not worried about what the geometric part is behind of that, because it's just really what is the area of the sector. Do you need to know? No. So all you need to know is this is not going to be exactly the same as rectangle that was dx dy. So this is different. This is more, okay? So delta A over here is just going to be dr d theta, because those are my variable. And then there is something which makes that different, and that's just really a constant, and it has to be always r, okay? So I'm going to go over the reason, geometric reason behind of that, but you do not need to know. So that the A is not dx dy because this is not a perfect rectangle. And then when you make the over this, what is the Riemann sum, and you add it and let this approach to infinity, that is just going to be double integration. So geometric region, why that extra r make that sector shape like a rectangle, is just really by area of the sector. If I can have this one nicely, okay? So this is more, let me just say highlighter, okay? So that's just what was going on. I make it to the sub pieces, right? I make it to the sub pieces. What I've done is just really cut it in r direction. End point minus the start point divided by number of pieces. This is in cutting in r direction. This is cutting in theta direction. This is cutting in theta direction. So end point minus the start point divided by number of pieces to make those sub sectors, I will call it. And then I pick that lucky point to be a star, okay? So this is my ith piece, same thing that I've done informally. This is just really nicer. And then I made that one to be half, or is just the midpoint, because it's easier, because that is easier. So that's a midpoint, because that is easier. And then that's just really the part I don't expect you know in this level, because it was for a long time ago. So the area of the sector, okay? So area of the sector from geometry, the basic geometry is going to be half of r squared theta. So if you don't remember what do we call a sector, so this is the whole thing is a sector, right? So this is what we call a sector. So the whole thing is what we call a sector. So it's half of r squared theta, the area of the in total whatever we have had, okay? So this is the reason that r is coming for every single integration, is because if you get the area is really the bigger sector minus the smaller sector. So I'm going to show you in the picture one more time. So this is the entire sector. But what I'm making right over here, which is here, okay? So it's not entire one, right? So it's just really going to be the big sector, which is here, and then minus the small sector, which is here, okay? So that piece left over is going to be subtract the biggest sector minus the smallest sector. And that's why it's just half of the biggest sector minus the smallest sector. And then by just really algebra, this is difference of a square. Difference of a square is just really like this. And that's just really what we call R star. And then this is difference of the R's, and this is difference of the theta. And this is why the R extra factor of R is here. Again, this piece I don't expect you to know as engineer measure, but math measures must know how to get that extra factor. What I want to tell, or what I want to use, or what you need to know for integration here is after the Riemann sum, let me just, this is so slow. Okay, after the Riemann sum, this is what happening. If you start with the double integration in XY coordinate, first of all, your x's is all in terms of R cosine. Then your y's is all in terms of R sine. And then you have area of your region. So that area of your region, if it's supposed to move to this, what we call polar system, has to have extra factor of R right over here. This has a name. This is really a special name. So every single changing variable from every system of coordinate to another system of coordinate has a constant, has a transformation that named as Jacobian of that transformation. For us, the transformation started from rectangular coordinate and moved to the polar coordinate, and that Jacobian for changing from rectangular to the polar is that extra factor of the R. So what is just really the process? You must just say, okay, when I'm moving to the rectangular coordinate to polar, x must be written in terms of R cosine, and then y must be moved in this R sine. And then if I want to write dx dy, I can't directly write dr d theta. I have to write the extra factor of what we call r dr d theta, okay? So one more time, the reason that extra factor of r is here, because what is in pieces, what is here in pieces of your polar, let me just move on here. So these pieces are not a perfect rectangle region. So it's not really length times width to get the area of these pieces. So it has extra factor, which is just really subtract the bigger sector from the smallest sector of here to get this region. And that tells you, okay, that tells you why when we have dA, which is dx dy, is not really the same as dr d theta, and I have extra factor of r, and that was just really right over here, which I proved it, okay? Which I proved it right over here, okay? So all I need to remember from this part, to do the polar integration, always add a factor of r, which we call it Jacobian for this changing variable. Okay. Is there any question? And if you let the number of pieces to be more and more, that's what we call double integral. Is there any question? So this is the page or the thing that we need to know. If you have to move from the rectangular coordinate, if you have to move from rectangular coordinate to the polar coordinate, you have to pay for that. What's that payment? R. So you are moving from rectangular coordinate to the polar to make your job easier. So you must pay for that, which is that Jacobian. The payment is that Jacobian, okay? And then everything must be in terms of polar. So X has to be in terms of polar, Y has to be in terms of polar, limits has to be in terms of polar. And again, to make your job easier, to do the integration a lot easier. If you don't have the polar, if you practice your other section problems, you have to do the trig substitution. So that's just really to get rid of those trig substitution to make the job easier. Okay. Is there any question about this one? So this is the main thing that we need to remember. Is there any question? Okay, that's one more time. Remind us why that extra factor is right there, because that's not a perfect rectangle. So it's not width times length, it's width, length is r d theta. So that's just really to remind us, and that's my first example. Okay, this is a really good example. I think I need to make it a little bit smaller. I need room to write my solutions. I hope this is enough for you. Okay. This is a really good example because you need to remember everything, right? So you need to remember from the algebra how to make the graph in 2 dimension, and from this course how to graph three-dimensional, three-dimensional surfaces, okay? So the question is, evaluate this thing. It has nothing to do with the polar. How do I know it's easier to do this one in polar? Any idea?
Because whenever you do X and Y in terms of R cosine and R sine, it'll make it easier, right?
Exactly, because of exactly equation of the circles, right? Because of x squared plus y squared. So these are the signs, huh? So these are all the signs. So when you say x squared plus y squared, x squared plus y squared, x squared plus y squared means you have a circle. Whenever you have a circular region, it's easier to do in polar system, okay? So yes, it will be a lot easier form of the integrand and limits of integration if I go by this polar. Okay, so then what's the graph? Actually, this is just a circle with the radius of, I think we have a cool, so let's just erase this one. Here, no, that wasn't the one. I need more. Okay. Oh, it doesn't have circle. How come? This is ellipse, right? Okay, forget about it because I just need to erase half of that. Okay, so then I have a what is circle with the radius of 1, and then I have a circle with the radius of 2, but it says upper half, right? So since it says upper half, this is going to be really this piece. Sorry, it's going to be really this piece only. Okay, if I erase the bottom piece, I think is erasing the entire one, but that's fine. I just redo it. It's not a big deal. Okay, so this is what is the region of integration. Is that fine? Okay, then I want to set the limits of integration, obviously in polar, because we have had this one at the beginning of this section. It says it's a lot easier to do in the polar. So then I have to set the limits of integration in, I will say 99% of time is easier to do, or is easier to start with the theta. I will, in the entire course, I will start always with the theta, and then I will say constant is most of the time is the theta, is the constant one. You know the rule, right? You know the first one must be the constant, right? So that must be constant. Do we have something to just really in polar system not to be constant? Yes, it's just really type 1, type 2, the same as really XY coordinate system. It does have the type 1 and type 2. But at least I can say for this course is always the first one is the constant one, okay? The first one is always the theta. So can you tell me what's the limits for the theta for this one? 0 is always here. All the way to the pi, yes. And then next one is the r. So for the r, do you see I'm trying always for every single thing to make the arrow, because that helps me to see what's the lower than upper, right? So for example, when I'm looking to the r is increasing, right? Always pointing out the origin, right? So then I see is a blank from 0 to 1. I do not see anything from 0 to 1, but it's just really filling, or the region or shaded part is starting from just really 1 to 2. So that's radius is from 1 to 2, right? And that's just really perfect because they are constant. I don't forget that extra factor of what we call Jacobian or changing variable right over here. So then the integrand is 16. Okay, so let's just do over here. So I have 16 factor out the negative. So I have x squared plus y squared. But we know in polar, this is r squared. We know in polar, x squared plus y squared is r squared, okay? So this is easily 1U substitution, am I right? So this is going to be 1U substitution. This is going to be 1U substitution. And I'm going to practice something that I encourage you strongly to do. This is just really to skip the steps for the integration. Why? Because I don't need really that much steps for integration, okay? So it's saving your time, it's saving your life if you just really trying to do most of the thing is possible to do in your head. I think it's possible, okay? So that's why I'm asking you. So this is supposed to be my u. And then if I take the derivative, it's just going to be like this. Is that fine by now? So what I'm supposed to do in my head is integration of square root of u du, which is u half plus 1 divided by half plus 1. So this is what you need to have in your head. So I'm not worried about the first one for now because it's just really a constant. So I'm just doing the inside. This is going to be what is it? U, which was originally half, but you integrated. So then you have plus 1 divided by half plus 1 because of the integration. And then I did not change anything because I did have the u substitution at the same time in my result. I plug in my u was 16 minus r squared, and then I have 1 to 2. So remember, because that u substitution that you have over here, there was some extra constant, don't forget about it. So this is just really what I need to take care. So if you have this du, it has to be minus the half, right? So it has to be minus half. Is that okay? So it's minus half of that. So this the steps that I strongly recommend you to do it on your head, okay? So to save your time, because that's just what we have learned in Calculus 1. And the thing that takes time is just really when you try to change the limits of integration in U and then get the values. That takes time, okay? So I'm trying to do this one. That is 1/2 plus 1, so it's 3/2. Reciprocal is 2/3. 0 to pi, so this is 16 minus 2 to the second and to the 3/2, and minus 16 minus 1 to the second to the 3/2, and then has nothing to do with the theta because that's just really a constant. So this is 12 to the 3/2, and this is 15 to the 3/2, and then whatever is integration from 0 to pi, is just really theta, which is from 0 to pi, which is pi minus 0, which is pi, okay? So again, I'm writing here like this because I just want to say, don't write this piece. Always, you know, if you're integrating from constant, it's just really upper limit minus lower limit, and that's it, right? So it's minus 1/3, which is pi over 3 of 12 3/2 minus 15 to the 3/2, and that's your answer. Okay, even this piece, this little piece, which is integration of 1, you don't need to write it. Is it fine? Is there any question? Is there any question? Okay, so this is just really with the details over here. But before moving, because I'm going to stop here. But what I have done actually right over here, because this was what is z equals 16 minus x squared minus y squared, which is just really the equation of a sphere. If you don't remember why this is the equation of a sphere, because you have z squared equals 16 minus x squared minus y squared. If you square both sides, and that's x squared plus y squared plus z squared equals 16. Okay, so what you have done over here, you can just imagine, was originally just one what is it, a sphere in 3 dimension, and then you have had the radius of your sphere, and then somebody just said, okay, I'm not just going to be entire, it's just really making something with the radius of 2 and something with the radius of the 1, which is that blue region. So blue region is really in positive part, so it's right there. Imagine you are finding the volume of that blue region when the top is just really the sphere. The top is going to be the sphere. So is the roof of this solid is going to be the sphere, but it's just really that piece of that ring when you get the region, the volume of that region. Does it make sense? Okay. So this was just really the easiest case. Why? Because everything was constant. It does have type 1 and type 2, but it's not really that much important to set it first in type 1, type 2, because as I said, for 99% of the time in our course, this is going to be the first one, which is always the constant. Okay, so then we have easier job. But still, I will do more examples on Wednesday. On this one, and then I'll start triple integration, because triple integration has nothing, it's really same thing. It's just you will have one more term to do with the dz. Okay, I'm going to stop here, but one thing I need before I forget to say, please remember, if you are supposed to do your test in DSS, I must change your setting in my MATLAB to do in extended time. Okay, so email me individually and remind me individually to change your setting if you're supposed to have 1.5 times of the usual time through the DSS. I got from one student and it was just fine, and usually it's just really all was from the beginning of the semester. Okay, so if is there anyone else, so some reason just wants to do any process, so let me know. Any question?
How long you're gonna stay on for? How long are you gonna stay on for office hours?
Right now?
Yes.
It doesn't matter.
It's okay, because we were gonna do the we can show you our homework. You said.
Oh, you have done for that part? Are you ready? You can do it on Wednesday. Whoever is ready, you can do it right now. So let me just log into the gradebook in the other computer. Then I can just show you. I mean, as you are showing. Okay, how many of you are doing that one? So except that, is there any other question, guys? So except that, one thing that I forgot to just do to check your Blackboard discussion board to see whether you have any questions. Sorry, I forgot, but I will do it, okay? So keep going and send the questions on discussion board based on weekly discussion board, okay? So except the homework thing, the extra credit for homework that you can show it right now through your, what is it, camera. Do you have any other question? So I'm trying to go to the grade book and see where is that column that I have set. Extra credit homework chapter 14 is here. Okay. Who do I have first?
Hey, Professor, can you see me?
Mm-hmm.
Okay. So here's 14.1.
Okay, so let me make it bigger. So maybe it's good idea to stop sharing this thing and even, well, sorry.